Hi, good morning. So for this lecture, we'll be discussing about resetting and setting index using the reset index function, using the set index function, and we will discuss about data frames with multiple index and indexing and selection of data frames with multiple indices. So let's get started. So I executed this one already. So we import numpy as np, import pandas as pd. So there are cases when you want to reset an index. So let me create an example first. So np random will set the seeding to 100 so that if you create random values or numbers, we will have the same. So that's np.randomSeed. So let's create a sample data frame. Data frame is equivalent to pd data frame. So let us create a random integer of 5 by 5 matrix. So if you remember, np random dot randint. So we generate numbers from 0 to 19 into a 5 by 5 matrix. Then next one, so we define the index. So I will use a shortcut here. So row 1, row 2, row 3, row 4, row 5. So if you remember, we will use the split function. So this converts a string into a list. So this will be our index. And we have C1, C2, C3, C4, C5. Then also we will use the split method. And we execute this one. So shift enter. So I think np is not defined. So let me execute this one. I thought I already execute this one. So let us execute this once again. So this one is our data frame. So remember, this one is data. This is the index name in terms of a row. So R1, R2, R3, R4, R5. And this one are column names. So C1 to C5. Now, in some cases, you want to reset your index. So we will use that using the reset index function. So how will you do the reset index? So you do the reset index by using this specific function on a data frame. So for example, so df dot reset index. So shift enter. So as you can see, now we have our index not from R1 to R5 anymore, but from 0 to 4 already. So remember also that using the reset index, this is does not occur in place. What I mean is this is not a permanent change. So if you execute df once again here, so it will be reset again to its original value. If you want to reset the index permanently, you place the parameter of in place, which is true. But this time I will not do this. So maybe later. So again, df reset index. Let me comment this one. So something to remember. This will not occur in place, not permanent. So you make this permanent, you provide the in place equals true value. Also, you can also use set index. This is our method to a list. If you want a series or a data frame to be the index one. So let me demonstrate this one. So for example, I have a new data frame. So remember, you can create a new column. to insert a new column to a data frame. So for example, I have A, B, C, D, E. And again, I will just use the shortcut of split. And I have here DF. So this is now the state of our data frame. So C1 to C5, then I have a new column comprises of A, B, C, D. So you can make the new column as the new index by setting it as a new index by using this function. So I will comment this, use the set index to set a specific column as the new index. So let's demonstrate this one. So df.set index, this one is new. So Alt enter. So as you can see, our new index now is ABCD instead of R1 to R5. So remember again, this is not a permanent change. So as you can see here, let me show you again the data frame. So R1, R2, R3, R4, R5 is still our index, although we set this as the new one. But remember, this is not permanent. If you want to do this permanently, so again, remember, you place the in-place parameter to true. So we will be doing this as a permanent setting of index. So Alt enter. So if you see this one, this df, so we will have a permanent change. So again, df, so shift enter. So this one is a permanent change. You can also create data frames with multiple index. So let me show you what I mean. So you can create data frames with multiple index from arrays. And you can see we have different index levels. So we will not be using this thoroughly inside the course, but I want you to know that this multiple indexing with data frame exists. So for example, I got an array of R1, R1, and we have also R1, and for example R2, so 3 R2s. Okay, then another list inside the list. Let's say 1, 2, 3, and another 1, 2, 3. Then we'll have the H index, the hierarchical indexing. So H index will be a PD dot multi-index, so dot from arrays, which is our ARR. So if we execute this one and we take a look of our H index, so this will be a multi-index of list of tuple, so R1 and 1, R1, R2. So what I want to do here is to show you we can have a data frames with multiple indexing. So let us create a data frame out of the multi-index. So for example, data frame is equivalent to pd dot data frame. So again, we'll generate a random numbers. So let's say random dot rand end normalize. So this one by 6 rows, 2 columns. So our index name will be our multi-index, which is the H index, and A, and we have AB in terms of column. So let's execute this one. So as you can see, now this is a different kind of data frames. This is still a data frame, but we have R1, R2 as our index. Also, we have 1, 2, 3 and another 1, 2, 3. These are grouped together, if you can see. So we will not again thoroughly use this in our course, but this will become handy when we are doing data visualization. So also, you can also create this one. So let us create this one using another method. So you can also create this one from tuples, if you remember tuples. So again, we create different index levels. So for example, we have outer. So let me just copy this one for quick typing. So this one is the outer index. So this one is the inner index. So 1, 2, 3, 1, 2, 3. So then we create also an H index, but this time we will use the zip function. List zip of outer and inner. So what this means is that we are creating a list of tuple by zipping this one. So the object of the zip is to partner this outer and inner pairing. So as you can see here, R1, 1. So R2, 2. So we have R1 of 3, then R2 of 1, and so on. So created a tuple, a list of tuple. So you will use extensively this one for machine learning, usually for data visualization, the zip function. So again, if you want to see this one, so let's create the same data frame. So df equals pd dot data frame. So before we create a data frame first, so let me define first. I forgot to define the H index. So pd dot multi-index dot from tuples. So now we're creating a multi-index from tuples. Then the H index. Then we create another data frame. So let me just copy this one. So this is the same, but we're creating this using a tuple. So basically the same, but different values because we're using random. So this one is a data frame with multiple indices. Now, since we have multiple indices, I know you're curious about how we can select a specific portion of a data frame with multiple index. So let me display this data frame again for our reference. So if you want to select, how about this one, this portion. So again, if you remember the dot loc function, so we can use that. So df dot loc and the name of the outer index, which is R1. So basically we're selecting here this portion of the data frame. So we use Alt Enter. So that is 1, 2, 3. So we're selecting this one. So how about we select a specific portion of the index? How about we select this R1 and this specific portion, which is negative 2.13 and 0.91. So again, you can also use the df.loc R1. Then you're inside now the R1. Then same concept, you also use the loc of 3. So Alt Enter. So now you're selecting this portion of the data frame. So R1, 3. Okay, so let me show you the data frame again. So it's clear. So you're selecting the R1 here. Then we got 3, which is negative 2.13 and 0.91. Also, you can also use the cross-section function of the data frame. So we'll do the same thing, but we will use the xs function. So df.cross-section of R1. Okay, so basically we're doing the same example, but without using the LOC. So if you want to select R1 and index 3 of R1, so dfxs. So you can pass a tuple of values, which is R1 and 3. So the same. So we're selecting here portion of R1, which is negative 2.13 and 0.91. So the good news here is that this one is much more flexible. So again, let me show you the data frame. How about we select in terms of cross section? I want to select R1 and R2, index both the one index of both R1 and R2. So you can do this one by using the cross section using level. So for example, you have a cross section using level. So df.xs. So I'm selecting the index 1. Then you provide another parameter which is level, which is equivalent to 1. So we'll basically selecting here. So this one is level 0, R1 and R2, which is this one is level 1, 1, 2, 3, 1, 2, 3. We're basically selecting the level 1, but we're selecting the index 1. So the result will be this one. So it's negative 1.08 and 2.06. Then we have 0.59 and 0.058. So if you're not comfortable with using levels, you can set index name. So for example, so setting index names. So we have df index.names. These are properties of the data frame. So groups, properties, methods, and numbers. So if I execute this code, so our data frame will look like this one. So this R1 and R2 has specific level names already. So not just explicitly 0 or 1. So you can do this now. So let me copy this one. So copy. So this time let's create let's select the level 3 of in terms of numbers. So we're basically selecting this one, the negative 2.13 and negative 0.14. So Alt Enter. So you can do this in terms of multiple indexes. Also, you can specify a specific column while specifying a specific levels. So for example, so let me copy this one. If you are interested in the column A only, so you select after I'm interested with index 3 of level numbers, but I'm interested only with column A. So Alt Enter. So this will become a series already because it's only one column. So as you can see now, so A, we got 2.13 and we got 0.14. If you want B, you can also do this one. So Alt Enter. So these are the flexibilities of a multi-index data frame. So remember, we will not be using this much of this multi-index data frame in terms of our course, but these are advanced data frames. So these are very useful in data visualization. So for the next topic, we will be discussing about simple handling of missing data in terms of using Pandas. So again, good day and see you at the next lecture.